Hello everyone, welcome back to the YouTube channel of Developers and Coders Club. Today we are here to discuss the problem Subarray removal which came in recent context of CodeChef. In this question we will be given a permutation A of length n and we need to figure out two indices L and R. And what is the task of that L and R? That we remove subarray from AL to AR from A. Then the remaining sequence would be a permutation. And the score of this operation is equal to R minus L plus 1. So we want to maximize this one, and the condition is that A still remains a permutation. So if you see in this one that if we remove these two one 4 and 5, then the remaining is 2 3 1, that is also a permutation. So for this one the score can be R minus L plus 1, that is 2. That is simply a size of the sequence which we are removing. So for this that is 2. In this one there is a condition that the sequence would not be empty. Like you cannot remove all of numbers from this one because after that the sequence will be empty. So that is not a permutation. So in this one we can remove only these four numbers. So for this that will be 4, and in this one, like if we remove only this number, then that is 1. Other than this, if we remove like just think we are removing 3 and 4. So 5 and 2, that is not a permutation. So in this one we are only allowed to remove only this one number. And in this one, here also only 5 is allowed because if we remove like 5 to 4, these three numbers, then 1 and 3, that is not a permutation. So for this also, the answer is 1. So now what is the final point that we need to figure out, that if you are removing a segment from L to R, so what is the condition for that? There is the two conditions. First is that the maximum element of sequence that will be equal to n, that should be present in this segment L to R. And what is the next condition? That the minimum value of this L to R should be the maximum value of remaining permutation plus 1. What I want to say that in this one you can see that the minimum value of this is 4, which is maximum value of this, that is 3 plus 1, that is 4. So the minimum value of this should equal to n minus R minus L plus 1 minus 1. How we got this one? Just tell me that if you are selecting the segment from L to R, then what will be the size which will be left? That will be n minus size of this, that is R minus L plus 1. I am denoting that with us. This is the size which will be left. So what we need to say that the maximum value of that will be equal to the size of that permutation and plus 1, that is 4. So n minus s, that is remaining size. Okay, this is plus 1 and plus 1. This would be the minimum value of L to R. So if we simplify this one, then n minus R plus L and minus 1 plus 1, that will be got cancelled. So for any segment from L to R, if the maximum value of that is n and the minimum value of that is n minus R plus L, then we can remove that one. Now our target is to maximize this one. So there is a simple thing that we cannot iterate for every subsequence of the sequence. So what we need to do for making it optimal solution, we will first figure out that what is the index of 1. Just denote that with s, and what is the index of n, and just denote that with e. Then there is a condition that we will not consider 1 in our segment, and we have to consider n in our segment always. We will not consider this one, and we have to consider this one always. So what I want to say that, just think that in our sequence 1 is present here and n is present here, then we know that we can choose any sequence from this to this. The only condition that we don't want to add this one. and we also don't want to remove this one from our segment. So we can choose our minimum size of segment can be this, and the maximum can be this one. So in this one, what we will do that I will make a while loop that will start from this one, and from this side that will start from this one. So if anywhere we go to this condition true, then we will stop. So if you see the code, then you will make more clear that first of all we are calculating the index of 1 and n. Then if index of n is less than 1, what I want to say that if n is before 1, then in this side we only can move till index of 1 minus 1 till here, and in this side we can start from 0. So you can say that our starting index is 0 and our ending index is index of 1 minus 1. And if n is after 1, like in this one, then we have to start from index of 1 plus 1, and we can go till the end of the sequence. So we have to start from index of 1 plus 1, and we can go to till the end of the sequence. So this is the L and R on which we can calculate the sequence. So this is the function which we will discuss later, that this is giving me the minimum value from L to R, and that is x. So if x is equal to n minus r minus L, that is same as I consider here, n minus r plus L. So if that is equal to this one, then we will say that okay, our answer can be this one, and otherwise what we can say that just think that we are considering like 3, 4, 5, 6, 7. So if because of any reason we cannot consider this whole sequence, so which element we can left, 3 or 4? Just think that if we remove 4 from our segment, so there is a simple condition that if we are removing 4 from that, then obviously we cannot take 3 also in our sequence. Why? Because we are saying that the element in our sequence should be conjugative. Like from minimum element to maximum element, all elements should be present in that. But if you are removing 4 and adding 3 in our sequence, then from 3 to 7, 4 will not be there. So there is a condition that if you are want to remove any one of from 3 to 4, then we will remove 3. Because if we remove 4, then obviously we have to remove 3 in that condition. So what I want to say that here, that if array of L is less than array of R, then we will remove L from our segment and we will proceed one further in L. And otherwise we will come backward in R. So that is how we are calculating the, like if minimum is equal to that one, then we are stopping there and making our answer equal to that. Now our main question that how we are figuring that what is the minimum value from L to R. For that you either can use segment tree, or you can use square root decomposition, and as I used here, that is sparse table. So I used here sparse table. This is the code for that. You can check that. I will put a description in a link in the description for that one. You can check there. Time complexity for this will be O of n log n for creating the matrix, and O of 1 for this query, O of n for this query, and O of n log n for this build. So that's all about this question. I hope you all understand it. You can get the code and the link for this sparse table in the description. See you in the next video. Till then, happy coding. Bye bye.